Hello, everybody. Welcome to our webinar. Our topic today is quality floors from start to finish, choosing and preparing wood subfloors for finished flooring. My name is Mary Ewer. I'm the Eastern Region Manager for APA, the Engineered Wood Association's Field Services Division, and I'm going to serve as your moderator today. APA is a nonprofit trade association representing manufacturers of a variety of common structural engineered wood products. In addition to quality verification and product testing, APA conducts research to improve engineered wood products and systems where they are used. We also educate users and specifiers on the product's intended use and potential application. Before we start today's webinar, I need to cover some housekeeping details. Handouts of the slides can be found on the control panel on your screen. Bob's presentation will last about 50 minutes. I'd like to note that today's webinar is approved for AIA and ICC continuing education credit, and a certificate will be provided to use for other organizations that self-report continuing education. After the conclusion of the webinar, you can get your customized certificates of completion. Your feedback is very important to us. On your screen, you see a QR code. If you open your camera on your smartphone and point it at that code, a link will pop up to take you to the survey on this session. We will show you this link a few more times throughout the course today. Our presenter today is Bob Cusick, Engineered Wood Specialist for APA based in New Jersey. In his role with APA, Bob works with designers, building officials, and builders on the various engineered wood products that are used in buildings today and consults on engineered wood use in construction applications. Prior to joining APA, Bob spent 20 years as an engineer providing technical support for a major manufacturer of engineered wood products. He's a professional engineer licensed in 8 states and received his Bachelor of Civil Engineering from Villanova University and a Master of Civil Engineering from the University of Delaware. Again, welcome to our webinar on the topic of quality floors. I will now turn the microphone over to our speaker, Bob Cusick.
Thank you, Mary. As Mary mentioned, today's topic is quality floors from start to finish, choosing and preparing wood subfloors for finished flooring. I'm sure most of you reviewed our objectives as you're signing up for this webinar, but I'll quickly review them again. Our objectives are to understand APA products and how they relate to the installation of finished flooring systems. Look at the building tolerance associated with these systems, and learn how moisture affects these systems and the importance of conditioning these materials prior to installation. I'll start by reviewing some basic terms and definitions associated with flooring installation. Look at moisture and how it affects wood structural panels and ultimately your finished floor. Discuss the preparation of the subfloor and underlayment to receive various finished floor assemblies, and touch on many assemblies that may have been developed by the Tile Council of North America. So why do we care about moisture control or installation? What problems or concerns do we see? These are things we will cover today. As I said, the name of the presentation says it all. Our goal, quality flooring. These floors are expensive and the homeowner's expectations are high. The only thing more expensive than installing these floors is installing them twice. With a little information, we can get it right the first time. Some issues that you may find with some of these surfaces include cracked tile that can vary from a hairline crack to a major crack. Telegraphing of uneven surfaces under the floor finish can also be an issue. This can sometimes occur at the underlayment or subfloor panel edges. Also, nail pops showing through some finished floorings can happen. Gapping between the hardwood floor joists. Some of these gaps may be minor and open and close with seasonal changes of moisture, but they also may be larger and align with subfloor or underlayment edges. Large gaps may not close with a seasonal change in moisture. Cupping of hardwood flooring, where the hardwood planks are curved up or down, creating an irregular surface. Squeaks of the floor finish are also a possibility. As stated, I'll start with some definitions that we'll be using today. Knowing and using the correct terms is an important step in building a quality floor. Let's start with plywood versus OSB. Plywood is made of veneers, where OSB is made of strands. Plywood can adhere to the PS1 product standard which is a prescriptive standard based on veneer grades. So only plywood can be manufactured in accordance with this standard. Where PS2 is a performance-based standard, which allows both OSB and plywood to be manufactured in accordance with this standard that provides more flexibility, allowing manufacturers to be more creative in how to make these panels to meet our structural requirements. A lot of people don't realize this, but OSB is made of layers or strands, just like plywood has layers. They have layered veneers in plywood, there's strands in OSB. That's really the main difference. These layers are oriented in alternating directions that give panel strength in both directions, with the strongest direction typically oriented in the long direction of the panel. Unlike plywood, the wood grain in any one layer of OSB is more randomized. This gives OSB panels a slight edge when it comes to stiffness and plane. I'll also mention that both plywood and OSB are manufactured with moisture-resistant adhesive and undergo structural tests in both their wet and dry conditions. Both OSB and plywood are available with an Exposure 1 or exterior bond classification. When I start with definitions, I sometimes like to start with what Merriam-Webster tells me. They define the subfloor as a rough floor that is laid as the base for the finished floor. Typically in wood frame buildings, subfloors are made of oriented strand board or plywood. Underlayment is a special grade of plywood on top of the subfloor and under the finished flooring. You also hear the term sturdy floor. So what is sturdy floor? APA rated sturdy floor, also known as single floor, is a combined subfloor underlayment product produced from either OSB or plywood. So now that we understand some terms of the surfaces that serve as the base layer for the finished flooring, let's define the different flooring types that will be the focus of today's presentation. Wood flooring. This category can be broken down into three main types. We have solid wood flooring that is a solid piece of wood from top to bottom. Engineered wood flooring that is also real wood from top to bottom, but is normally made using wood veneers glued in opposing directions. This is similar to plywood, but the top surface veneer being a high-grade veneer of the wood that the flooring is representing, like oak or cherry, for instance. Composite engineered wood flooring contains real wood on the wearable surface only with a composite backing and core material. Vinyl flooring has a long history, but recent improvements with this product have made this a popular go-to choice for home builders and remodelers. In the past, you're likely familiar with the standard sheet or solid vinyl tile, which is a thin layer of solid vinyl bonded to a thin felt or fiberglass backing. These products are usually fully glued down to the wood underlayment. More recently, luxury vinyl plank or luxury vinyl tile has become a popular choice. These products consist of a more durable, thicker wear layer bonded to a multi-ply planks. These products can be floating or glued down systems. Tile floors have always been a workhorse, particularly popular in kitchen and baths where they are constantly exposed to water. Tile flooring generally falls into two categories of materials, ceramic or natural stone. Lastly, I'll mention carpet and pad, since it is a finished flooring, but generally doesn't have very strict installation requirements. APA sturdy floor functions very well as the base for carpet and pad, but won't be a primary focus of this presentation for carpets. The first key to the installation of a good subfloor starts with the supports. As I say, you can't build a good house without a good foundation. The same can be said about installing a quality flooring system. Inconsistent spacing can contribute to an uneven floor. Let's consider this joist layout with various joist spacing and joist span lengths. Framing floor areas dramatically different can result in areas of the floor performing differently. We have an area here with short spans that's adjacent to an area with long spans, next to an area with a wider joist spacing, and an area where the direction of the floor joists change. So let's consider where there may be a differential deflection in this layout. Let's think about the deflection of point A here, for example. Look at the proximity of this location relative to the beam and post only 24 inches away, where the deflection will likely be less. It'll be even zero at this post. Could this cause an issue with your finished floor? We can better balance this design with consistent joist spacing and spans and eliminate the differential deflections in the floor system. As I said, a quality floor starts with a quality foundation, but a quality foundation or floor starts with the design. So now that we have a balanced level floor framing system designed, let's look at what floor sheathing is recommended. Take a look here at Table 1 in our APA Tech Note performance-rated panel subfloor under hardwood flooring. We find recommendations that align with those from the National Wood Flooring Association. This association provides guidance on the installation of hardwood flooring. I'll also note that the absence of specific direction from vinyl flooring manufacturers, this can be a good basis for selecting a subfloor for those products as well. You'll note from this table that the recommended span rating of the panel exceeds the floor framing spacing. Note the recommendation of a 20-inch rated panel for a 16-inch joist spacing and a 24-inch rated panel for a 19.2-inch joist spacing. In other words, the span rating of the floor panel is a higher rating than the floor framing spacing. This results in a stiffer floor. I would also draw your attention to the footnote B alternate, where the National Wood Flooring Association allows a 2-layer subfloor to provide a stiffer base. It's not to say that you can't use a rated span for the subfloor, but considerations to using a thicker underlayment under the finished floor can also improve performance. Now it's time to get our subflooring installed. As these are typically a glue nail system, we need to lay down the adhesives in a manner to prevent premature dry out of the adhesive. First, wipe away any water, dust, and debris from the joist before applying the glue. Spread only enough glue to lay only 1 or 2 panels at a time. This helps to ensure that the panels will be firmly and permanently secured to the joist. The glue should be applied with a 1/4-inch diameter bead to framing members, either in a continuous line or in a serpentine pattern for wider joists. Be sure to complete all nailing of each panel before the glue sets or skims over. APA also recommends that you glue all tongue and groove joints by spreading a thin 1/8 inch bead of glue in the groove and avoid glue squeeze out. I understand this is not a common practice in the field, but it is highly recommended. APA has a publication, our APA Builder Tip, Construct a Solid Squeak-Free Floor System. It's an excellent resource that describes several considerations on how to prevent floor complaints and callbacks with proper floor sheathing installation. Here you see the recommended 1/8 inch space of the subfloor at the time of installation. This space can be increased as long as the code required 1/2 inch bearing is met. Gapping of subfloor panels is important to allow for this panel expansion. Failure to allow space for these panels to grow when acclimating to its environment can result in a raised edge or a buckled panel. Note that the gapping of underlayment placed on top of subfloor may differ than the spacing of the subfloor, as APA recommends 1/32 of an inch for underlayment panels, and we'll discuss that in greater detail a little bit later in this presentation. Fastening of subfloor panels is an important detail, and based on APA field observations, often not done correctly and has been frequently identified as a source of problems with finished floor quality. Pay attention to APA nailing recommendations. Install subfloor fasteners 6 inches on center at the supported panel edges and 12 inches on center at the intermediate supports. But I'd also caution you to check local codes for increased nailing schedules, as they may be required in high wind or seismic areas. Fasteners should be placed a minimum of 3/8 of an inch from all panel edges and ends. I would note that with the narrow dimension lumber joist only being 1.5 inches wide, to avoid a shiner where the nail misses the joist entirely, it is a common practice to drive the nail at an angle or slant nail. In this case, slant nailing would be used to maintain the 3/8 inch edge distance of the panel and provide adequate edge distance in the lumber joist below. Additional information on slant nailing can be found in APA Technical Note 058 titled Slant Nailing. So now that we have reviewed the fastening requirements for the subfloor, we should look at the fastening requirements of the underlayment, the panel that goes on top of the subfloor. The minimum nailing for underlayment varies based on the underlayment thickness. APA recommends 3D by 1 1/4 inch ring or screw shank nails for 1/4 and 11/32 performance category panels, and a 4D by 1.5 inch ring or screw shank nail for a 19/32 or 3/4 inch performance category panel. Fasteners, as I mentioned, should be installed 3/8 of an inch from the panel ends and edges. Fastener spacing also varies based on the panel thickness. So for 1/4 performance category panels, the fasteners are placed 3 inches on center around the panel edges and in a 6 inch grid each way in the field of the panel. For a thicker panel, 11/32, 19/32, and 3/4 performance category panels, the fasteners are placed in a 6 inch on center around the panel edges and ends, and in an 8 inch grid each way in the field of the panel. I'll also note on this slide that when installing underlayment, the panel end joints should be staggered or offset from the subfloor joist by 1 joist spacing and panel edges by 2 inches. So you're looking to offset these panels from the joists below. So keep that in mind when installing an underlayment panel. This is an example where you can see the tile is cracked at the edges of the plywood underlayment. Given the proximity of the tile cracking at the underlayment edge led to a concern that there may be a problem with the underlayment. Let me highlight the panel edge with a red line. In this building, 23/32 category underlayment was being used. We found that generally the fasteners were installed on a 12-inch by 12-inch grid and greater than the recommended 3/8 of an inch from the panel edge, represented by the yellow lines. Note that some fasteners are as much as 2 inches from the edge and that the spacing of the fasteners are closer to 12 inches rather than the recommended 6 inches. Improper fastening spacing allows for greater movement at the joint, and this can create issues with the finished flooring line cracking along the tile along the panel edge as shown here. So how flat is your floor? Flooring flatness plays a big role in assuring a quality installation of your finished flooring. Carpet and pad can hide a lot of issues, but resilient or hard flooring can show these flaws. The National Wood Flooring Association recommends 2 flatness criteria depending on how the floor is attached, recommending 3/16 inch in 6 feet or 1/4 inch in 10 feet when using a floor fastener greater than 1.5 inches, and 1/8 inch in 6 feet or 3/16 of an inch in 10 feet when gluing, floating, or using mechanical fasteners less than 1.5 inches. Many hardwood flooring manufacturers recommend the stricter 1/8 inch in 6 feet or 3/16 inch in 10 feet criteria. The North American Laminate Flooring Association is a bit more challenging, primarily because of the differences in luxury vinyl tile or laminate flooring. There are greater variances with these products, with thickness ranging from 1/8 inch to 3/8 inch, and some laminates may be more brittle or flexible than others. The North American Laminate Flooring Association notes the floor should be flat and highlights that most manufacturers recommend a maximum of 3/8 inch on a 6-foot radius. Doing some research among the various vinyl tile manufacturers found that some variance is shown in the slide here. In the absence of any specific recommendation, I would suggest reaching out directly to the manufacturer to confirm the recommendations and get their advice on how flat their floors need to be. Tile presents its own challenges. The Tile Council of North America Handbook for ceramic, glass, and stone tile installation recommends a flatness of 1/4 inch in 10 feet for tiles with edges less than 15 inches and 1/8 of an inch in 10 feet for tiles with at least one edge greater than 15 inches. One factor that can influence the flatness of the floor is panel ridging. Panel ridging can occur along panel edges because of heightened moisture content in the panels from various sources, including direct exposure to rain or snow, or heightened moisture over crawl spaces. Oriented strand board panels exposed to moisture conditions for extended periods may exhibit thickness swell, typically near the panel edges. Paying attention to these moisture sources can help minimize panel ridging. Tests show, however, that such swelling does not result in any loss to structural capacity of the panel after it dries to an in-service moisture condition. But if it does occur, it can be easily fixed by sanding the edges. I emphasize it's very important to ensure that the moisture content of the subfloor is acclimated with the condition of the finished structure prior to sanding. I would also add that many APA members manufacture enhanced subfloor panels that are more resistant to weather and moisture with a reduced tendency towards thickness swell. These products may be a consideration, particularly if long construction times or high exposure to moisture is anticipated. And recall that proper fastening can play a role in panel ridging. So I'll again emphasize the importance of proper spacing between fasteners and that 3/8 of an inch from both the panel ends and edges. Additional causes of ridging can also be twisted, uneven or misaligned floor framing, debris on the framing, installation of adjoining panels with the back face and the face surface alternated where the tongue and groove joints don't match, overdriving the tongue and groove joint edges. If not capped, the compression on the panel edges can occur due to panel expansion, mixing panels by different manufacturers. If you experience panel ridging, APA has a customer service tip, ridging in single layer floor panels, that provides additional information on this topic. As mentioned, another factor that can affect floor flatness is framing alignment. We can see in the photo on the left the dip in the floor. Looking at the framing alignment from below, we see that the light behind the straight edge that indicates this joist is higher than the adjacent joist. This alignment will result in high and low spots in the floor surface above. The key to good performance in floors is the right combination of subfloor, underlayment, and finished flooring. Plywood underlayment panels resist dents and punctures from concentrated loads and provide a smooth base for carpet, tile, hardwood, and vinyl flooring. APA-rated sturdy floor panels can be either OSB or plywood and are designed as a combination subfloor underlayment. Sturdy floor panels provide a smooth base for certain types of flooring, finished floorings. They're an excellent base for carpet and pad. A separate layer of plywood underlayment, however, is recommended for some types of finished flooring. APA's tech note on the selection, installation, and preparation of plywood underlayment provides guidance on typical panel flooring specification based on the finished flooring installation. Table 2 in this guide breaks down the different floor finishes and recommended subfloor and underlayment combinations. As I said, carpet and pad are easy. As we mentioned, APA sturdy floor being a combination subfloor underlayment panel is appropriate for single layer construction, whereas rated sheathing is better paired with an underlayment panel, noted in Table 1. Hardwood flooring underlayment panels can be optional, but I'll go over that a little more in a bit. Vinyl or other resilient floor coverings or glued down carpet are also better paired with any Table 1 underlayment. Ceramic tiles should be paired with an underlayment, but as with hardwood flooring, tile installation offers options that I'll review later. As we saw that Table 1 was referenced in our Table 2, recommending underlayment under carpets with a rated sheathing for subfloor and vinyl or thin coverings, let's take a look at Table 1. Table 1 shows several panel combinations that will be considered an underlayment panel. You note that generally the face grade is a B or better, or the face is sanded. This combination provides for the smooth surface needed under many floor finishes. Table 3 in our selection, installation, and preparation of plywood underlayment publication recommends thickness, fastener size, and type that considers if the underlayment is being installed over a smooth subfloor or a lumber subfloor or an uneven kind of rough surface. You'll recall that Table 2 in APA selection, installation, preparation of plywood underlayment guide said that the installation of underlayment is optional. That doesn't necessarily mean you simply decide to install an underlayment or not. The National Wood Flooring Association also provides some guidance on when to use an underlayment. This guide details a single layer system where the underlayment isn't required depending on the subfloor thickness category you are using. So looking at some common joist spacings, if your joist is spaced at 12 or 16 inches on center, you can use a 19 30-seconds category plywood or a 23 30-seconds category OSB. 19 2 inches on center, you can use a 23 30-seconds category plywood or OSB, and a 24-inch on center system could use a 7/8 inch category plywood or OSB. I've also included the minimum span ratings alongside these performance categories, so we can see how the previously discussed APA criteria aligns with the National Wood Flooring Association guidelines. I'll note that the span rating is preferred since the span rating indicates the structural use of the panel, not just the thickness. So what do we do with vinyl floor coverings? The North American Laminate Flooring Association provides guidance stating the floor meets the local building codes, be structurally sound and deflection free, repair squeaks, plane the high spots and fill the low spots. This specification is general in nature as these floor coverings come in many different thicknesses and can be installed differently. Some materials are glued, some are fastened, and some will simply float on the floor. Therefore, I believe when dealing with these products, it is best to consult and get the manufacturer's recommendation, as the North American Laminate Flooring Association does indicate that the manufacturer's recommendation supersedes theirs. Just a quick observation regarding deflection free. I note that all wood floors have deflection, both the panels and the joists, so it's challenging for an engineer to read deflection free knowing that these panels and joists will in fact deflect. Building codes generally require an L/360 deflection limit. Consider a wood structural panel installed on joist space 24 inches on center. This translates to an allowable deflection of 0.06 inches or about a 1/16 of an inch. But understand that the APA rated panels are rated to support 100 PSF live loads at this deflection criteria. So the actual installed deflection will be much less, say in the order of 1/32 of an inch for a code prescribed 40 PSF live load. So let's look at some of the manufacturer recommendations. I found some variance between manufacturers on the requirements for underlayment. Some of this may be related to significant variance of the floor finishing thicknesses and installation methods. An example of a specification from manufacturer A simply states that if the surface of the wood subfloor is not smooth, a 1/4 inch underlayment panel should be installed. But they don't get specific on the specification other than that they be dimensionally stable, a smooth, fully sanded face, be resistant to both static and impact indentation, and be free of any surface components that may cause staining, such as plastic fillers, marking inks, sealers, etc. APA underlayment panels with fully sanded face would meet this criteria. Manufacturer B, on the other hand, specifies a CDX or OSB subfloor, including the performance category with an associated joist spacing. But I'd like to point out a couple red flags with this specification. First, I noted that the dated reference PS2-92 and PS1-95. There have been several updates to these performance standards since 1992 and 1995. I'll also highlight that OSB cannot be PS1 rated because PS1 is a plywood-only performance standard. OSB can only be manufactured to a PS2 standard. So they have specified a nominal 3/4 inch thickness, where panels are currently produced to performance category standards such as 23/32, for example. So to me, this feels like a really dated specification or recommendation that's in need of updating. I'll also note the underlayment specification, to me, is a little unclear and may want to be checked. In this example, where an underlayment grade particle board with a minimum density be used. I note the particle board is not OSB. Particle board is very susceptible to moisture damage and is difficult to nail down, as it is also susceptible to flaking when nailed. It's also a non-structural material that really doesn't add any stiffness to your floor system. I would consider an APA underlayment grade panel could be used, but I advise caution when you see these types of specifications with the red flag that you don't understand everything. I encourage you to reach out to the floor manufacturer and clarify these requirements. I'd also like to comment on the CDX specification, as it is sometimes misunderstood and is really dated as slang terminology for a plywood panel with a C grade face veneer and a D grade face veneer that was manufactured with an exterior adhesive back when plywood was manufactured with either interior or exterior adhesives. Today, all plywood is manufactured with the same adhesives, but do have an exposure 1 or exterior bond classification that shouldn't be confused with adhesive type. Using current terminology, this specification typically refers to a CD exposure 1 panel. This example here from manufacturer C specifies subfloor requirements for flooring products that require a 1/4 inch or thicker layer of APA plywood underlayment. They recommend suspended or raised subfloor that is 18 inches above grade with a well-ventilated airspace below. They also specify that the subfloor simply must meet the building code, assumed for deflection purposes, and that the moisture content of the subfloor be less than 13%. This manufacturer also indicates the subfloors to be an APA sturdy floor equivalent. They also caution that a single layer wood subfloor increases the potential for staining or damage in a multi-layer system. The specification also goes on to specify the permissible grades of APA plywood as the underlayment panel. I'll note that these grades, as noted here, are represented by Table 1 and Table 2 in our APA selection, installation, and preparation of plywood underlayment guide. So now let's take a quick look at tile. The Tile Council of North America has published multiple assemblies that can be used for the installation of tile over wood subfloors and other surfaces. These assemblies can be found in the Tile Council of North America Handbook. Additionally, APA has published our technical topic, ceramic tile over wood structural panel floors, that details many of the TCNA assemblies that can be used. As you can see by the table, there are several factors that should be considered when selecting a tile assembly. These include the service classification, maximum joist spacing, and the tile size. These assemblies detail the subfloor and underlayment requirements and may specify no underlayment, a plywood underlayment, cementitious underlayment, or other options. Rather than review these assemblies in detail here, I encourage you to download our APA technical topic, it's number TT006, and use it as a guide in selecting the appropriate assembly for your specific application. We briefly discussed the importance of controlling moisture to control potential thickness swell in the subfloor. But when it comes to installing a quality finished floor, moisture can play a great role. If you look at the installation requirements from the National Wood Flooring Association, the North America Laminated Flooring Association, the Tile Council of North America, and APA, what they all have in common is the subfloor and underlayment should be dry. You will find reference to that basement and crawl spaces must be dry. I'll emphasize this again, they should be dry. We need to recognize that moisture management of the job site and in the completed house plays an important role in a quality floor. So what are the two main sources of moisture that can affect your flooring? The first is moisture due to direct wetting exposure to rain or snow. Dealing with direct wetting is pretty straightforward. Keep the rain or snow off, get the house under the roof, get the windows and doors installed, and get the water off quickly if it does occur. The second source is ambient moisture, and it's more subtle as this moisture source is in the air. Sources of ambient moisture are humid environments, damp crawl spaces, propane heaters and basements, as these heaters produce a significant amount of moisture when operating. Poured concrete basement floors that are installed after the wood floor is installed. The main takeaway is be aware of your moisture sources and make sure you can control them. Ambient moisture is more challenging since the source of this moisture isn't as intuitive. This moisture can enter the house through the basement or crawl space below the flooring. The possible major source of wood intrusion is at our foundations. Proper draining away from the foundation is critical, especially when the level of the water table is changed from its natural state after construction. Much of the same holds true for crawl spaces. Note that a vapor retarder extends across the floor and up the walls to reduce the amount of moisture that enters the crawl space from the ground below. There are two ways a crawl space is typically constructed. Either vented or vents along the perimeter of the foundation allows for a free air exchange that helps keep the ambient moisture down. An alternative to the use of the ventilation in crawl spaces that may be allowed in your area is to provide conditioned air in the crawl space in lieu of the vents. But one method or other must be used. A poorly vented unconditioned space is a recipe for disaster. Note that both types of crawl spaces are included in the International Building Code, Residential Code. I will note an observation that I've seen with an unvented crawl space during construction, in that it was closed up and unvented and poured concrete, and that introduced a lot of moisture during construction. So even in an unvented crawl space, be aware of this additional moisture that can occur during construction. Similarly, full basement foundation walls will have perimeter drainage and drainage with a vapor barrier under the slab to reduce the amount of moisture from the ground. Note that more information on this topic is available at APA's Build a Better Home set that not only has information on moisture resistant foundation construction, but information on controlling mold and mildew, moisture resistance for roofs and wall construction. I'll mention this set as all our literature is available for download at www.apawood.org. So let's get into a little science. Let's look at some thermodynamics. Understanding a fundamental concept of thermodynamics is useful in understanding moisture intrusion. Heat flows from warm to cold. Air moves from high pressures to areas of low pressure. Vapor moves from areas of high concentration to areas of low concentration. What this means is basically heat, air, and vapor move from more to less, always seeking equilibrium. Water vapor moves from areas of high concentration to areas of low concentrations. So if more water vapor exists inside the home, it will move to the outside. If more water vapor exists outside the home, it moves to the inside. Since it is very small, water vapor can move through many building materials. If allowed to move through the building envelope, the risk of condensation exists. This is why the building codes require the installation of a vapor retarder on the warm side of the wall. The vapor retarder keeps water vapor away from cold surfaces, which prevents condensation. Now that we know that moisture is our enemy, how does it affect the subfloors and ultimately the finished floor? I'd like to take a look at a possible construction scenario timeline and think about how moisture content changes as the construction progresses. Let's first consider a subfloor that has been recently installed. Wood structural panels, both OSB and plywood, are manufactured at very low moisture content and can arrive at a job site and be installed with a moisture content as low as 2 to 6%. But after heavy rain and snow, the moisture content of these materials can rise to as much as 30% or more, which results in expansion of the unconditioned subfloor in thickness, length, and width. Remember the 1/8 inch space recommendation between panels that we mentioned? This is to allow the panel to expand in the length and width direction. Otherwise, panel buckling may occur, which may affect the flatness of your floor system. So again, remember to gap those panels. But as we progress through the construction process, we've now installed the roof and windows and the floors begin to dry. Maybe it drops down to a moisture content of say 25%. Depending on where your project is constructed, it may stay at this level, 25%. So let's assume we now bring in our hardwood flooring, which may be very dry with a moisture range of 6 to 14%, and put that on our wood subfloor that had a moisture content of 20 to 25% since our HVAC system is not currently operating. Remembering that moisture levels travel from high to low concentration, the moisture will start to leave the subfloor and migrate into the hardwood. It's looking to balance these two systems. When this happens, the hardwood floor wants to expand, because as we've learned, the wood expands as the moisture content increases. We should also consider that since the moisture migration is predominantly from one side, the expansion is greater on the bottom, which can result in greater expansion of the bottom of the hardwood compared with the top, and cupping of the boards can occur. Note that this cupping is greater with wider pieces of hardwood. We'll now come into our home and we'll turn on the HVAC system, and the moisture content decreases on both the hardwood and subfloor begin to shrink. This can result in the beginning of gaps in the hardwood joints that begin to open, as well as nail pops that can occur as the subfloor shrinks. As the floor continues to dry, the cupping remains, but the gaps may become a little more severe. This is sometimes more noticeable when the hardwood joints coincide or are near a subfloor joint. At these locations, you not only have the gap that resulted from shrinkage of the hardwood, but the gap that occurs from the shrinkage of the subfloor that can result in a larger cap at the subfloor joints. This is called panelization, where you see larger caps associated with underlayment or subfloor gaps. Here you see gaps in the flooring identified with the white papers. Smaller gaps can occur across the panel face with larger gaps at the subfloor panel joints. We discussed how gapping can happen as the subfloor and hardwood flooring shrinks. While less common, it is possible that the hardwood flooring can expand relative to the subfloor. If there isn't sufficient space at the wall to allow for the expansion of the flooring, the panels can start to buckle up or push up. In this case, the installer should install the hardwood with a gap at the baseboard. This gap is typically covered with a quarter round at the bottom of the baseboard over the hardwood edge. In this case, the hardwood has been pushed up off the floor. Here's another issue that we sometimes see with flooring. There's both a gap and a hump in this floor. On first glance, this may look like a shrinkage or expansion issue, but closer inspection, a different issue is found. This gapping and hump in the hardwood occurred due to the floor framing. With dimension lumber joists installed flush on an engineered wood beam like LVL, joist shrinkage can create irregularities in the floor surface that will manifest itself either as a hump in the floor, gapping of the hardwood over the beam, or a cracked tile. One solution is to set the dimension lumber joist slightly higher than the engineered wood beam to allow for this shrinkage. Or maybe a better option is to use engineered wood products such as I-joist, LVL, or LSL that are less susceptible to shrinkage. This is the panel at the girder we saw a few slides back. Cumulative contraction of the subfloor and the hardwood flooring led to the large gap at this panel joint. Also, the joist dropped at the poor ledger connection, which caused the appearance of the hump above. In building, we tend to think of nail pops having an issue with the drywall, but they can also occur in your floor system and create a problem with your finished floor. How the fastener is installed is critical in reducing nail pops in the floor. When attaching plywood and underlayment to a subfloor, use nails having a length approximately equal to the total thickness of the subfloor and underlayment layers. I'll emphasize that one of the best precautions against nail popping is to use the appropriate APA recommended ring or screw shank nail. Too long of a nail may ream a hole through the subfloor that may loosen and minimize the penetration into the lumber joints, reducing the potential for the fastener popping because of lumbar shrinkage. Remember, if using pneumatically driven fasteners, that foot pressure should be applied near the fastener to assure contact between the underlayment and the subfloor. APA's builder tip to minimize nail pops is an excellent resource to help reduce the likelihood of nail pops. First, choose the right material. Dry lumber or engineered wood framing such as I-joist, glulam, or structural composite lumber that is manufactured dry reduces this chance of shrinkage. Select the proper fastener. As I mentioned in the previous slides, when attaching plywood underlayment to a subfloor, use nails having a length approximately equal to the total thickness of the subfloor and underlayment layers. Also, to reduce nail pops, use a deformed shank nail like a screw or a ring shank nail to help reduce this cumulative pop. And prepare the framing surface by attaching wood structural panels sheathing to clean, level, or flat framing surfaces. There was an article in the Journal of Light Construction, November 2014, that stated that most drywall cracks and nail pops, open miters and woodwork, warps and bows of doors and panels, or buckling and open joints between floorboards are due to moisture. It goes on to state that the problems are most extreme and expensive with wood flooring, but all the issues can lead to some pretty negative perceptions by the clients. This highlights the importance of controlling moisture and the need for the builder to make sure the products are dry and acclimated. If our project is wet, how do we go about drying it out? Job site fans and dehumidifiers are good tools that can help in getting the project dry more quickly. Portable cooling units or electrical heating units, as shown here, can also be used to dry the house. Note that I mentioned electrical heating units to dry the house. So in addition to the risk of operating a fuel-fired appliance in a closed space, they also create moisture as a result of combustion. The creation of this relatively large amount of water is why fuel-fired appliances should not be used to dry the house. Heat pumps can be used for cooling and heating, but they set them up outside the house, can be used to condition the house. This is a temporary HVAC system that you could build. But ultimately, the installation and operation of the house's own HVAC is also a good source. National Wood Flooring Association actually recommends that the house's HVAC system be operating at the time of the flooring installation. So once the house is dry, it's time to bring in our underlayment and finished flooring materials. APA's builder tip recommends the plywood underlayment be allowed to acclimate by standing them on edge and separating them to permit air circulation for several days in the room where they will be installed. So we want to get that air flowing around all sides of the panels. Likewise, the finished flooring materials, especially the hardwood and luxury vinyl tile, also need to be allowed to acclimate. Stacking the boxes of finished flooring in the room isn't really the best method to acclimate these products. Like with underlayment, air should be allowed to circulate around these materials to allow for quicker acclimation. We now have a general understanding of how moisture can affect a finished floor, but are we really ready to install it yet? We know we need to keep our materials dry and dry them out when they get wet because moisture can affect the finish. We see many references that note the subfloor must be dry. Make sure the moisture content of the subfloor, underlayment, and finished floor are similar. But what is dry and how do we know when it's dry enough? What are the recommendations related to moisture content of the subfloor at the time of installation? You'll find specifications for manufacturing trade organizations as well as product manufacturers. Note the manufacturer's recommendations generally will take precedence. Trade organization recommendations will usually take precedence if the manufacturer hasn't provided guidance. However, consideration of the most conservative specification most likely provides for a quality floor. Let's see some of the guidance provided by the National Wood Flooring Association, a hardwood manufacturer, and the North American Laminate Flooring Association. We see that the National Wood Flooring Association and the hardwood manufacturer are similar in the requirement that the subfloor and hardwood be within 4% for narrow boards, less than 3 inches in width, and 2% for boards wider than 3 inches in width. The North American Laminate Flooring Association, they make no mention of relative moisture content between the subfloor and finished floor. We see where a hardwood flooring manufacturer has specified that the subfloor moisture content not exceed 12%. Both the National Wood Flooring Association and the North American Laminate Flooring Association reference alignment with the condition of the facility, and they make a geographical reference for seasonal changes. In the past, I'll note that the National Wood Flooring Association installation guidelines stated that in most regions, a dry subfloor that is ready to work on has a moisture content of 12% or less. And this likely serves with the specifications that we saw from that manufacturer. Currently, both the National Wood Flooring Association and the North American Laminate Flooring Association in their recommendations recognize that wood doesn't have a set equilibrium moisture content and may vary with the environment and provide geographical references to wood moisture content. So looking at data from the U.S. Department of Agriculture, both the National Wood Flooring Association and the National American Laminate Flooring Association, they provide maps that note the average moisture content or the equilibrium moisture content in wood. They divided the United States primarily into 3 geographic regions, with most of the United States having an average moisture content of 8% and really ranging from 6 to 10. And the dry Southwest had an average moisture content of 6% that ranged between 4 to 9%. And the damp, humid Southeast average moisture content of 11% and ranged from 8 to 13%. So when we look at it from this perspective, we kind of see where that 12% recommendation was a high-end recommendation for the Southeast, and it may change a little bit graphically on where you're building. So now that we have our moisture content target for the subfloor, with consideration of the region of the installation, it's a good starting point. I've mentioned the National Wood Flooring Association Wood Flooring Installation Guidelines several times. This guide has 12 pages dedicated to the acclimation and moisture testing of materials prior to the installation of finished flooring. I'll touch on a couple of key points, but really recommend you get familiar with this process. This publication is available for purchase on the National Wood Flooring Association's webpage at nwfa.org. So they recommend upon delivery of the hardwood, take moisture readings on 4 boards per 100 square feet, and moisture readings on subfloor of 20 locations for the first 1,000 square feet and 4 readings per 100 square feet after these initial readings. So we kind of know what our targets are, how many readings we're taking. We've got all this good new knowledge, we're ready to go take some readings. So let's look at some of the tools that we're going to use. There are 2 basic types of moisture meters that you'll see in the industry. And I'm sure the first question is, which is the best one to use? And basically what I'll tell you is the answer to that question, the best one to use is the one that is used. Too many times when we visit sites that have issues with their flooring products, we find that no readings were taken. I take this as a sure sign that something may have been off at the time of installation that could have prevented the problems that we saw with the flooring. So with that in mind, we also need to know how to use it. There are pin type meters. They measure the moisture along the depth of the pin and at that location only. They're very specific. And remember that these meters need to be calibrated for the wood species. So you need to know the species of the plywood, the subfloor, and your finished material. Pinless meters, on the other hand, take a broader reading, but they can be affected by density, and the signal penetration can vary for different meters. My best advice is to understand your meter in use. I'll mention that the National Wood Flooring Association is a great resource. I encourage you to check them out, and also encourage you to check out the manufacturer of the various moisture meters to learn how to use these tools. So now that we know our targets and our tools, it's time to put them to use. Take delivery after the envelope of the structure is fully enclosed and protected from weather, and after all wet trades such as concrete, masonry, plastering, drywall painting are completed. Verify that permanent or temporary heating, cooling, humidification, or dehumidification as appropriate are operating. Remember that fuel-fired introduced moisture and should not be used. In dealing with moisture, it is best to understand that most hardwood flooring is delivered dry or less than 10% moisture content. Upon delivery, take your readings as recommended by the National Wood Flooring Association to establish your baselines. That was a lot of information. I'd like to take a quick moment to review our agenda and focus on the big takeaways. We reviewed some terms and definitions, looked at the moisture effects on wood structural panels, the preparation of subfloors to receive finished flooring, and we've touched on tile assemblies a little bit. But the main takeaways that I want to leave you with are floor flatness. A quality floor starts with a quality base. This starts with ensuring the floor is flat. Make sure supports are aligned, look for thickness swell, and address these issues prior to installing the next steps, be it the underlayment or the finished floor. We can't mention this enough, moisture. Most issues with finished flooring can be associated with moisture. Panels got excessively wet and swelled, differential moisture levels when finished product was installed. Best rule is keep your products dry. If they do get wet, remove the standing water, drain the water away, brush it off. Prior to installing the next steps, make sure you're installing them on good dry material. Acclimate your materials so there isn't a significant moisture difference. Follow the details. We highlighted there are many different types of underlayment that would be suitable under all these floor finishes. Plywood underlayment can be used where the floor seems rough, even if not required. We saw different criteria from the Tile Council of North America that depends on tile size and 7 assemblies detailed in our APA technical topic, ceramic tile over wood structural panel floors. We discussed the installation and fastening requirements for subfloor and plywood underlayment, but at the end of the day, these details need to be shown and followed to ensure a quality floor. At this time, I'd like to thank you for attending our webinar today. I hope you found this information helpful and something that you can use on your next projects. At this time, I'd like to turn this back to Mary to see if we have time and if we had any questions that came in during the presentation.
Thank you, Bob. That was a lot of really good information. We have had some questions come in. I'm trying to keep them organized as we're going as well. First of all, I'd like to remind you that your feedback is really important to us. You can again see the QR code on your screen that will take you to today's survey. Just open the camera on your smartphone or smart device and a link will take you directly to the survey. Please take a minute and fill out our survey. We use that information broadly. So Bob, it looks like do have a couple of minutes for questions, which is great. One question that came in is, why should I use sturdy floor that has an underlayment face when I plan on installing another underlayment?
Okay, that's a very good question because I actually do get this from time to time. So I'd just like to really touch on that subject again. So although sturdy floor is suitable for direct application of carpet and pad, sometimes an additional thin layer of underlayment is recommended under a tile or sheet flooring. It might be a little thinner, or fully adhered carpets where they're little, they can telegraph imperfections. So this added layer, it restores that smooth surface over the panels, and because they may have been scuffed or roughened, during construction, and they don't receive the same sufficient sanding. So when plywood sturdy floor with sanded face is specified, it's a different level of sturdy floor. The surface is also suitable for direct application of some resilient floor coverings. So if a sanded face panel is to be used, take care and make sure during construction to prevent damage or roughening of the sanded face. Tongue and groove edges are recommended to be glued under thin floor coverings to ensure these snug joints, and they may need to be sanded as well to get that flat surface.
Great, thank you. What about screws? Can screws be used to attach an underlayment?
APA, we recommend using ring or screw shank nails for the fastening of the underlayment to the subfloor. We don't really have recommendations for fastening underlayment with screws. One advantage that I note with nails is that there's little give when changes of moisture if the loadings occurs. The screws don't have as much given, can be susceptible to snapping their heads during and after installation. This is not to say, however, that an appropriate structural screw intended for wood assemblies can't be used. If you do use screws, the size should be equal or greater than the recommended nails, and the spacing should never be greater than the recommended nail spacing. But always use a screw intended for a structural assembly. Drywall screws should never be used because they can be quite brittle and the heads may pop off.
Great, thank you. Is there a need for a filler between underlayment gaps?
For this, I think we do have some information on fillers between the gaps between the underlayment edges, and I think that should be found in our selection, installation, and preparation of plywood underlayment document. So shortly before the floor covering is installed, you can fill all the edges, gaps, splits, damage areas with hard, non-shrinking, quick-setting filler. We'd recommend you check that with the manufacturer, because we want to keep in mind that the filler restrains the edge of the panel from closing that can cause wrinkling or ridging. So if you're installing a filler, the panel should be dry prior to installing the filler. Make sure that filler dries hard, does not shrink, is quick setting. Some fillers may expand slightly as they cure, so make sure they're fully cured, and sanding the ridge, should also be done. It's one thing, I'll point out, we have the closer gapping requirements, with the underlayment layer, so you may not need that filler.
All right, great. And then, should the underlayment be glued?
Gluing the underlayment of the subfloor. Our publications, the installation, again, we're going back to that installation and preparation of subfloor underlayment guide. We generally advise against gluing or using construction adhesives. One of the issues you need to be aware of when using adhesives is they can develop staining problems with certain types of resilient sheet flooring products. So that's a recommendation that, APA, we don't recommend gluing the underlayment to the subfloor. The fasteners, the form shank fasteners at the spacing that we detail out really should be sufficient to get your underlayment attached to your subfloor.
Okay, wonderful. And then I think we have time for one more. There were a couple of questions on moisture metering. And do we recommend a pin type or pinless moisture meter if you are taking moisture readings in a panel?
Yeah, this is always the challenging question. I've been on a couple seminars and webinars from the National Wood Flooring Association, and this topic does come up. First, I'll go by stating, APA, we're not an expert on moisture meters, so we really don't have recommendations regarding the type of moisture meter to be used. Reach out to the moisture meter manufacturer to see if they have recommendations. Let them know what type of subfloor, what type of underlayment you're using, what your finished flooring is, and get their recommendations for what work best in those materials. And I'll really emphasize that the best moisture meter used is the one that you are using. Even just get relative readings between them it's a step in the right direction, as opposed to taking no readings at all and just relying on feeling it with your hand.
Great, thank you. We are out of time for questions to answer during this Q&A. Thank you again, Bob. Like I said, if you had a question we did not get to, we will share those with our field services team and get back to you as soon as we can. Before we conclude, I want to touch on a few quick things. First, make sure you're signed up to receive our APA update newsletter so that you will be notified of future webinars and updates to APA publications and standards. To receive it, all you need to do from our homepage, www.apawood.org, is click on Sign In the upper right-hand corner of the page. In the drop-down menu, simply select Register. Then you will need to let us know what you'd like to receive from APA, which in this case is the APA Update newsletter. Lastly, APA has field staff located throughout the country. These talented people are available to assist design professionals, builders, and code officials, and are the people that will be reaching out to answer your questions. Their individual contact information can be found on our website, www.apawood.org. Please feel free to reach out and take advantage of this free resource. And don't forget to download the AIA or ICC Certificate of Completion. And with that, I'd like to thank you for attending. Have a wonderful day.